Buenas tardes a todos. A continuación, tenemos a dos expertos para hablar de la ergonomía, durabilidad y confort en botas de seguridad. Para esta ocasión presento a Matt Piotrowski, desde New Hampshire, Estados Unidos. Él es Lead Product Engineer y Co-Chair en Astm Footwear Committee. Y también presento a José Sanchez, Business and Marketing Manager en Timberland PRO. De igual manera, quisiera recordarles a todos que en caso tengan alguna pregunta durante la presentación, no duden en escribirle en el recuadro las preguntas para poder contestarlas más adelante. Good evening, Matt and Jose. It's a pleasure to have you both here.
Thank you, David, and good evening, everyone. My name is Matt Piotrowski. I've been working in safety footwear development and commercialization for the past 7 years. I've been in footwear for the past 12. For the past 3 years, I've been the co-chair of the ASTM Safety Footwear Technical Committee, and I've been participating on the committee for about 10 years now. In addition to that, I also sit on the Canadian Safety Footwear Technical Committee, and even before starting my career in footwear, I worked as a field engineer in oil and gas. So my background is very much tied into safety footwear and PPE. So today I'd like to discuss the two leading, most prominent global safety standards for footwear, being ASTM and EN ISO. So the history of both of these organizations is pretty lengthy. ASTM, which was formerly the American Society for Testing and Materials, was founded in 1898. They have over 12,000 active standards. There's 140 technical committees. And the standards are used across the globe, mostly in the Americas, but they're also used, throughout the Middle East and Asia and elsewhere. The Safety Footwear Technical Committee, which I'm part of, was established in 1993. And then for ISO, the International Organization for Standardization, they were founded in 1946. They have, almost 24,000 standards, nearly 800 technical committees. Also used across the globe, more focused in the European Union, but definitely seen throughout the world. And their Safety Footwear Technical Committee was established around 1980. So the first place I'd like to start is kind of how standards are created. So it's the same for both ASTM and ISO. The technical committees themselves are made up of a group of volunteers that consist of industry experts, and the users themselves, academia, so people from universities, insurance representatives, and safety professionals. As new standards are needed or even updated, there's a voting and vetting process that all these go through. So any negatives that come up for differences of opinions are put to a vote and dealt with accordingly. So there's a majority vote to get them to pass, but you still have to take into account any negative vote or something else to overcome. And so the goal of both committees is to provide, safe protection for everyday activities on job sites throughout the world. So that's really what we all go there to do, and that's our end goal that we keep in mind as we work on these. The other big thing to know is that both for ASTM and ISO, the standards are updated periodically. So this just makes sure that the protection that they're providing keeps up to date with what's actually going on job site or the workplace. So for both of them, it's approximately every 5 years, but there are some exceptions to that. So as we get into it, one of the differences between the two is the certification process. So for both ASTM and ISO, testing is conducted at third-party laboratories that are independent of the footwear manufacturers. So they'll test everything to the test methods and supply the test reports. Where it starts to get a little bit different between ASTM and ISO is for ASTM, the third-party lab that does the testing will issue the certificate of conformity, provided that everything passes. Whereas on the ISO side, there's these notified bodies that would review all the test reports and then issue the CE certificate. So the key difference here is a safety footwear manufacturer could test their product at a variety of test labs, and then the notified body that would issue the certificate would then review those test reports to make sure everything is in compliance with how the product is going to be marked. So that's one of the key differences between the two bodies. So the safety footwear standards are really broken down for both organizations into two main categories. There's the test methods, so how to test the piece of footwear or the component, and then the requirements that those test reports, the results need to meet to be marked and certified. So for ASTM, your test methods for all the protective functionality of the footwear is in F2412. For both ASTM and ISO, the years follow the date. So -18A this is the most recent revision from 2018. For ASTM F2913-19, so that was reissued in 2019. And F2913 is ASTM's slip test method. The requirements, which you're probably most familiar with for ASTM, would be ASTM F2413-2018, which is for safety toe footwear. Some of you may be aware of the soft toe standard, which is F2892, also published in 2018. So that's for a footwear that doesn't have a safety toe, but still offers protection, either things like electrical hazard protection, maybe static dissipative, or even a PR plate. And then the next big thing from ASTM is, I think within the next few weeks, we'll publish a minimum coefficient of friction requirement. So that's a big update coming from the ASTM world. On the ISO side, their test methods are ISO 20344, which was published in 2011. And then the one that everyone's probably most familiar with is ISO 20345, also published in 2011. That's for 200 joule safety toe footwear. They do have another standard, which I believe is not utilized very often, but it's out there, which is 100 joule safety toe. So the requirements are slightly less. And then last, they have also an occupational footwear or non-safety toe footwear that still provides other forms of protection beyond, safety toe. So this is the protections provided by each norm. Looking at this chart, you'll see that ISO has quite a list of features. And so this is one of the big philosophical differences between the two bodies. So ASTM their philosophy is to focus purely on protective components of the footwear. So we're only interested in providing protection. ISO, due to past history, also has requirements for material physical properties, durability, comfort, and things that don't necessarily pertain to protection. So that's where a lot of these extra features that you can certify footwear come from. What I'm going to focus my presentation today on is going to be the portions that do provide protection, just for the sake of time. And we'll go from there. So they both at the bare minimum provide, I'm speaking in relative to the safety toe footwear here, is toe impact and compression for ASTM. Then you have to have either electrical hazard resistance protection, static dissipative protection, or conductivity protection. The metatarsal or puncture resistance are purely optional, but at a minimum for F2413, you have to have impact, compression, and then one of the electrical protection choices there. ISO, on the other hand, their basic is impact, compression, material physical properties, slip resistance, durability, and some comfort features. And then they can add additional things like puncture resistance, anti-static, conductive, insulation gets cold, a number of things. And you may be most familiar with footwear that's labeled S1. So as you add to the safety basic, So you add anti-static, you add energy absorption heel, a closed seat region. Now that footwear can be marked as S1. And then whereas S2 would be all the features and benefits you get from S1 plus a water resistant upper. And then to go to S3, you would then get all the features and benefits from S2, but then you add a penetration resistant plate and a cleated outsole. So that's kind of how their marking works. And it really comes down to end use for how those are marked. The other major difference between ASTM and ISO is that ASTM tests one size of footwear. So for men's footwear, that'd be a EU approximately 43 or a US 9. And for women's footwear, women's specific footwear, we'd be tested at an EU 38 or a women's US 8. ISO, on the other hand, will test the smallest size, the largest size, and like a median size for their certification testing. So whatever size run is being offered, you test the smallest, the largest, and something in the middle. So yeah, they both focus on safety, and ISO adds in some comfort and durability requirements just based on some things they've seen in their market in the past. So now we'll talk about the actual features and benefits that provide protection. So ASTM uses a striker head. It's about 25 millimeters in diameter, circular. It's dropped at about 100 joules for the impact energy. On the ISO side, you have a wedge-shaped striker head instead, which is one of the major differences between the two. So for ASTM, when they're testing this striker head hits the rear portion of a toe cap. So it's the weakest point of the toe cap is how ASTM picked it. That's why they impact here. Whereas ISO, they come along the whole length of the toe cap when their impact striker hits. So when you see this difference of 100 joules from ASTM to 200 joules in ISO, that's mainly due to just the difference in where the impact striker head hits and the shape of it. So in ISO, you'll see most of this. As this hits here, a lot of the impact energy goes through the front of the toe cap. Whereas on the ASTM one, it's all has to be supported by the back edge. So the minimum clearance at the end of the day they're fairly similar. Again, this is to leave enough room so that if something falls on the front of the safety toe boot, that your toes are protected. So while the impact energy differs, it's not as drastic as just the numbers make it look. It's really about how they're tested. And I'll show a couple videos and some finite element analysis to demonstrate this. So could you play video 1, please? So what we're going to see here in slow motion is the ASTM striker impacting a naked toe cap. So for certification testing, the specimen would be cut from finished footwear. The foot that would be in the sample, and there'd be a piece of clay, and they would drop the impact striker here. But for demonstration purposes, the naked toe is easier. So you see that impactor come down on the back of the toe cap. And if you can play video 2, please. Again, so this is now the same toe cap being struck by the E and ISO striker. So you see it kind of have the same reaction. It hits the back, the whole length of the toe cap. And that's the big difference. And now can you play video 3? So here you're seeing finite element analysis of that same impact striker from ASTM. So all the orange in bright colors you were seeing was kind of the stress that was being shown on that toe cap. So you could see along the back edge, let's see better on this one. The back edges here at the top here is where all the stress from the ASTM impact occurs. And if you could play video 4. which is going very fast. You kind of see the green go through the front of the toe cap. So the stress curves are a little bit different from each toe cap. That E and ISO one is also seeing quite a bit of stress to that toe, safety toe. But at the end of the day, even with the difference in 100 joules between the impact energy, both standards provide safe, protective footwear. It's just the difference in the test method and how the strikers hit is why the impact energy differs so much. For compression, both standards are very similar. The big difference is the amount of force applied. So this test protects against a slow crushing event. The best example I like to use is in a warehouse where maybe forklifts are around. So if a forklift may weigh about 5,000 kilograms. So if one wheel rolls over your safety toe, this is kind of the protection that each standard is trying to provide. Again, they both use like a similar circular plate to apply the compressive force. But yeah, so they're very similar. The ISO method uses slightly more newtons. The minimum clearances are the same as the toe impact requirements. So it uses the same table because we're looking again to provide the same protection at the end of the day to the wearer. So for puncture resistance, this is meant to protect against stepping on a nail at like a construction site. It doesn't really take into account jumping off of a ladder or something similar. It's more for normal walking. And so what the test does is they apply a nail that's very similar again to like a 16 penny nail that's used commonly in construction. And the amount of force is applied and there can't be any puncture. This is a non-metallic puncture plate. This is a metallic version just for a comparison of the two. They both have the same requirement today. The big difference from ASTM to ISO is ASTM tests on components and ISO tests theirs on finished footwear. So if I had one with me, this would also have the outsole and midsole unit applied, and the nail would be tested going through all three pieces. Both standards flex test the puncture resistant plates themselves to make sure they're not going to delaminate or crack. And the same applies for corrosion resistance. As you wear, the footwear, as sweat builds up, that kind of eventually seeps down onto the plate. And so we want to ensure that it doesn't rust out and then fail over time, so that you're going to get long-term puncture resistance and protection. Today, both standards use the same shape pin, very, very similar. I expect ISO to update theirs a little bit for the fabric plate in the near future. I know that's in the works, but it's not official yet. So ASTM's test is slightly more stringent just because you don't get that extra protection from the midsole and outsole would provide, but they're very similar. Now kind of getting into the electrical protection. So ASTM and ISO both offer static dissipative footwear. That's what anti-static is providing, is just a way to dissipate static electricity buildup. They differ slightly in how they expect this footwear to be worn. So for ASTM, the static dissipative footwear is intended to be worn in clean environments where usually in manufacturing of sensitive electronics. Anything from satellites and microchips to auto industry, and I know they're used with airbags and the manufacture of airbags, things like that. And so the range offered from ASTM is they have a resistant range of 1 mega ohm to 10 mega ohms, which is called SD10. They have another range of 1 mega ohm to 35 mega ohms, SD35. And then they have another range, 1 mega ohm to 100 mega ohms, SD100. So the smaller that range is more meant to protect the equipment that's being worked on. So they they both have that minimum threshold of 1 mega ohm to protect the wearer from, stepping on a frayed extension cord or something on the job site. But the purpose of the footwear is really to also provide protection to what they're working on as well. Whereas on the ISO side, they kind of focus anti-static on the majority of their certified product will be anti-static. And so they chose to focus on static dissipants as one of the big safety features for them. So they test slightly differently. They use metal balls that go into the footwear, and then electrical leads are applied. They put 100 volts through it, and the resultant resistance range is anywhere from 100 kilo ohms to 1,000 mega ohms. So it's a very wide resistant range that the footwear can fall into. Whereas ASTM, we use a human subject to do the testing because all of this footwear, whether it's anti-static or static dissipative, needs to have humidity in the shoe to pass the static electricity through the outsole from yourself and down through the sole of the footwear. So ASTM tests with a person at the lab. They walk around in the boots or shoes for about 5 minutes to build up a little bit of that perspiration before conducting the test. And ISO kind of solves for it a little bit differently. They test with a dry condition and then a wet condition where the relative humidity is magnified to kind of get the same end use case of it being on someone's feet. And one key thing to note is as the footwear if the footwear gets dirty at the bottom of it, the effectiveness of the static dissipants goes down. So as you're wearing a boot like this out in the real world and it's caked in mud or whatever, the effectiveness of the anti-static or static dissipants drops rather significantly. So this is why ASTM chooses to focus on electric hazard protection. So this committee feels that it's much more likely in construction, general purpose, that you will come across a frayed electrical cord or extension cord or something of the like. And so the intent here is to provide protection from that. So it's up to in real world, it's about 600 volt electrical conductor that you'll have protection from. 18,000 volts is applied in the test method, but in real world, it's about 600 volts from the source. So in the standards mentioned earlier, 20345, 20346, and 7, this doesn't exist. So this is another one of the big differences between the two standards. And again, it comes back down to kind of philosophies of what to protect against. Next up is Mec Guards. Again, these are one of the test methods that's very similar. ASTM uses a 25 millimeter by 150 millimeter steel bar. ISO uses their same impactor that they use on the safety toe. And as you can see, the impact energy is approximately the same since the striker is approximately the same. And so these boots are meant to provide protection for above the safety toe. So when you're working in distribution centers, places where things could roll or fall onto the top, maybe fabrication onto the top of the boot, that provides a little bit extra protection for the bones of, just behind the toes. The major difference, though, is where ASTM strikes in ISO. So ASTM strikes about 90 millimeters back from the toe. ISO strikes about 105. So that's where you see this difference in the minimum clearance for the test result for the requirements. Because where ISO is hitting further back on the shoe, they're also hitting further up on the instep of your foot. So that's where about the approximately 15 millimeter difference in requirement is coming from. And then you may have noticed I skipped over conductive footwear. which is mostly due because they're, again, very similar test methods, and they're kind of a very specific end use of providing protection against igniting flammable gases or materials, things like wood dust and things like that. So they're not commonly used, but they're very similar requirements and test methods from both organizations. And then lastly, I'd like to go over slip resistance. Like I mentioned earlier, to date, ASTM did not have a minimum coefficient of friction requirement for slip testing. It's been in the works for 10 years. The test method has been around for a number of years, and it's taken the committee quite a while to land on a repeatable, reproducible minimum coefficient of friction. So what you see here of this greater than 0.4 coefficient of friction applied to a dry or wet quarry tile is what's going to be published very soon. So both ISO and ASTM use the same base test method, which was derived by a group named Satra out of the UK. And they did a number of studies with biomechanics and linking it back to the human gait and how walking and where slips occur, and then being able to then replicate it testing footwear. So this machine you see here is from Satra. You don't have to use this machine for the testing, but they really developed a test method that's really biomechanically based and linked back to real world people. The test methods differ ever so slightly, but they're very, very similar. The main difference is ISO requires you have to pass either SRA, SRB, or if you pass both, it can be SRC. And so for SRA slip, this is more meant for general purpose footwear. They test on a ceramic tile with sodium lauryl sulfate, which is a wetting agent found, which basically gives you bubbles in any type of soap. The requirements, greater than or equal to 0.28 or greater than or equal to 0.32. And then SRB, which is meant to be a very extreme slip circumstance where you're working in kitchens, maybe food manufacturing or fabrications with cutting dyes and lubricating oil and things like that. So conditions where you're going to be walking around on smooth floors that are contaminated with oils. So that's why this coefficient of friction is so much lower, 0.13 and 0.18. And ISO has it so that if you pass both of these conditions, you can label your footwear as SRC. The one big thing I wanted to note is how ASTM and ISO test. So they both test this what's called the forward heel slip. So this simulates heel strike. So this is where most slip and falls occur as your heel hits the ground. If you're on something, a contaminant that's really slippery, this is where a fall could occur. Where the two differ is ASTM tests on this backward four-part slip, which is meant to mimic toe off. So if you've ever been walking on like an icy surface and stepping forward and your toe slips, that's what this test is for. Where ISO does this forward flat slip, which I don't know. I've never had a slip incident where my foot's flat firmly on the ground, but I believe that's something ISO is looking to change. So both standards use the same kind of base test method. They test the heel slip where most slips occur, and then they differ a little bit in how they test the rest of the shoe. But I know we're running out of time. I definitely want to leave time for questions. So if we can open it up to the floor.
Buenas tardes a todos. I want to thank EFC o EFC, Proveedores Industriales, for the invitation to have a conversation with Matt this afternoon and open the questions section here today. And Matt, thank you. That was I really enjoyed the presentation. And as I have this opportunity and have been working with Timberland PRO since 2014, looking at international regions, including Latin America, and to explain a little bit of what I see when I'm traveling in Peru and in Latin America. For example, some of the questions that come up regarding products, safety, footwear, have to do with the norms. So in that regard, we have been able to see that the ASTM norms have been updated recently as far as 2018, and there was even one norm that you showed towards the end 2019. And also we saw EN-ISO was updated in 2011. Could you tell us a bit more about what these changes are from year to year, and maybe why ASTM is, updating more recently, EN-ISO not so recently, and those things I think will be interesting to all of us to learn more about.
Sure. So yeah, like I was saying earlier, both organizations try to update their standards approximately every 5 years. For ASTM, there's actually an update in 2017. There's one thing we had to change that we updated quickly, but for the most part, for these very established standards, not too much changes from revision to revision. So for ASTM in particular, how the methods are conducted and how the footwear is tested hasn't been updated since 2011. The changes were really to add, I mentioned SD10 earlier for static dissipants, to add that new lower range of 1 to 10 mega ohms, which was feedback we got from industry that they would like a tighter range, so then they know the footwear that they're buying will work for their specific end use. The other things that we've added since 2011 is that certificate of conformity I mentioned before. There was only a test report that would be issued by the third-party lab. And so today, in addition to that test report, we also get a certificate of conformity from the third-party labs. And I know EN-ISO has been doing a lot of work. I mean, 5 years seems a lot, but it takes a very long time to work on these test methods and test them and make sure they're reproducible, repeatable, and valid. And the main thing holding ISO up is actually due to Brexit. So most of the notified bodies in the EU were formerly in the UK. Now that they're no longer part of the European Union, all of those CE certificates for the past 6 months or so, all the safety footwear manufacturers have been working to transfer those certificates to other notified bodies that are still in the EU. So that safety technical or safety footwear technical committee has been working on a number of things. Like I mentioned on slip, I believe they're going to update how SRA, SRB, and SRC the testing is conducted. And I anticipate they'll probably have a new standard within the next couple of years, which would have probably occurred sooner if it hadn't been for Brexit.
Okay, no, I understand that. Thank you. That's very useful. Some of the other questions we often come across are, for example, when it regards to the many categories that EN-ISO addresses. And I think you explain it very easily to understand that some have to do with protection and some to quality. But if you could perhaps remind us a little bit about what is protection and what is quality, and maybe if where it comes to really protection categories, if they are more or less comparable or not.
Yeah, so the main difference comes down to I believe in the European Union, their market at one point was flooded with subpar, low quality safety footwear, and so the safety technical committee chose to regulate the safety footwear coming in by adding requirements for quality and comfort that wasn't occurring. On the other hand, ASTM hasn't seen that happen in any of the markets we represent. We haven't gotten that feedback, and so we've made the conscious decision to leave that up to the safety footwear brands themselves to provide quality and comfort and really longevity to the brand itself by providing those things to the end users. So, like I was saying, ASTM focuses on protection, puncture resistance, electrical protection, compression resistance. ISO has all those same features. They, in addition to to the quality parts of it, they also have things like, insulation against cold, which is really an outsole, midsole test. If you're walking in a cold environment, well, the temperature difference from the sole to the bottom of your foot, what will that be? And it's the same for heat insulation. And so ISO chooses to make it the same for all brands, where ASTM prefers to leave it some of those things in the durability and quality up to the brands themselves. So both standards provide excellent, safe, protective footwear. It's kind of a philosophical difference between the two committees as far as the additional comfort requirements.
Thank you. That definitely makes it clear, Matt. And I think very tied to that last explanation you were making, there is also that area you explained about the differences in slip resistance. And that is an area where you showed us that ASTM is going to establish the standards. It's going to publish it soon. But so today, I know, at least for Timberland, or Timberland PRO, that we do follow slip resistance guidance and procedures and best practices, and that these are based of the SATRA methodology. Would you be able to expand if you see that leading brands that use the ASTM method are following good practices when it has to do with slip resistance today?
Yeah, that's definitely the case. So all the leading safety footwear bearing manufacturers are very much focused on slip resistance. So no, ASTM hasn't had a requirement up until the near future. All the brands themselves have been working using that same SATRA test method, which I was explaining earlier, is biomechanical based. It tests the whole footwear. A lot of the previous test methods were meant for the flooring industry, and then were cobbled to test footwear on the side. So all the leading brands have been looking at this. They've all been using similar. Well, they all, at least for ASTM, they've been using the same test method. The great thing about this type of testing is you can change out the surfaces and contaminants to meet whatever the end use is. So one project I was part of, we asked for an airline, gave us the specs for their runway, some of their paint and their de-icing chemicals, and asked us to slip test that specific, a couple of specific products to see how they would perform for their exact end use. So even though it's not tied to the standards themselves, the test method can be used to really measure in situ kind of situations. So I know that have been doing things similar to that for even though there hasn't been a minimum coefficient of friction requirement until the near future.
Okay, no, thank you, Matt. And I think staying on that topic of slip resistance, because it's a topic that we usually find great interest in, in our conversations with key end users in Peru and throughout Latin America, and just in general in the industries. This question about the SRC method, sometimes I might hear, or we might hear, that SRC is somewhat considered some kind a gold standard, like something to achieve, and there are different views on that. Would you be able to explain to us again what SRC is about, and if it's really the gold standard, to say it in a way, for every situation, or maybe it changes depending?
Of course. So ISO requires SRA, which is testing on a ceramic tile with basically a soapy solution, and then SRB, which is tested on a smooth stainless steel surface with a very slippery contaminant called glycerol, most similar to like an oil. And so if you pass both of those requirements, then you can label the shoe SRC. So when ISO added that, if you pass both, the perception is that it is better. Where in reality, you're kind of making some concessions to be able to meet SRC. So what ISO was really intending was for SRA footwear to be general purpose footwear that you'd wear for everyday use, construction sites, outside. And then SRB would be for, again, kitchens, places you would encounter oily surfaces, which is pretty rare. So to pass both, you kind of the brands make concessions. It's definitely doable, but you make concessions on each side to do that. So I believe ISO is going to move away from the SRC standard in the next revision and just offer SRA or SRB. But yeah, it's kind of a give and take to be able to meet that instead of being able to focus on one surface.
Okay, no, that's very interesting because that question definitely has come up with, here and then throughout the years. So I think that's very, enlightening. And I think I can now ask David if he could come on because he has captured the questions from the audience and then we can have a conversation, the three of us. Thank you.
Thanks, Jose, and thanks, Matt, for the good presentation. Yes, there are a couple of questions for the public I want to ask you, Matt. The first one is, why ASTM standard certifies shoes for electrical risk, even if they have a steel toe, or they do not certify that?
So the electrical protection from ASTM is intended for underfoot protection. So the steel safety toe cap or even a steel PR plate don't really influence the results. It's more driven by the outsole, midsole, and the upper. So yeah, you could use any toe type and still have electrical hazard protection for that footwear. I mean, a number of brands provide steel toe products that are EH compliant. So yeah, it's more a stepping on a live wire test. That's kind of the protection that it's providing.
Okay, I have two more. The first one is, which standard is more rigorous, ASTM or NISO, regarding to the electrical issue?
For electrical hazard, definitely ASTM. It does not exist inside that ISO standard. I think there are separate standards that you could get electrical hazard certified ISO footwear to, but they would be outside of ISO 20345. It'd be a separate safety test method and things. So for general answer, ASTM for sure.
Okay, and here's the last one. ASTM evaluates puncture resistant plates?
Yes. So they evaluate the component itself. This right here is a non-metallic puncture plate. This is a metallic version. And so they're both tested similarly for puncture resistance. The requirements are a little bit different for delamination and flexing and the corrosion testing. But yeah, they test the component itself because you don't get the benefit of having the outsole or midsole attached to it like on ISO. But either way, you're getting puncture resistance from both requirements that are going to, protect you in the real world.
Yeah. So those were the three questions from the public. So, Jose, I don't know if you can explain more about Timberland PRO boots that they came to Peru's to end the presentation right now.
Yes, of course. Well, Timberland PRO was established as the industrial safety footwear division for Timberland, and Timberland is the creator of the original yellow boot, which was the first waterproof boot that was widely used by the worker in New England. And, having developed the brand and really looking to really focus on bringing the best technology and innovation to the consumer, we established the industrial division in 1999. And since then, we have come up with a number of important innovations in the market. Since our first boot with Timberland PRO, the Pit Boss, landmark boots like the Titan, and the systems of comfort, the very well-known anti-fatigue comfort platform that you know very well in Peru. So we have established ourselves as the leaders in the field of safety footwear in terms of innovation and comfort, as well as always, maintaining a quality and durability. We have also launched since 2015 our apparel line, which has expanded and now covers provides head-to-toe protection to the user, and it's a line that you have AFSA has acquired and is providing to users in Peru now with great success. So we have really developed a close relationship with Peru, and we work very closely at Timberland PRO with AFSA proveedores to really cater to the specific needs in Peru. We work very closely with the mining industry, but also other industries, doing a number of field visits. So it's really we're very, very proud of this partnership with AFSA. And yes, that's a bit of it. And I don't know, David, if you have any other questions, I'm happy to bring you other questions I have found along the road. And I have a couple of questions for Matt, perhaps, if there is time.
Yes, Jose, there is time for one more question, and then, we have to move forward to the next presentation. Then go on.
Of course. Well, Matt, so what do you see in your experience with brands that work on multiple standards? Timberland PRO, as you know, works with ASTM and has experience with developing EN-ISO product, even Mexican standard, Canadian standard, and Australian standard. So what do you see might be the learnings and the things that, how those things come together?
So the ASTM and ISO standards are probably the two most. The next would probably be the Canadian norms, and those three drive what's used for safety footwear around the rest of the world. So, like you mentioned, the Mexican norms kind of cobbled together from CSA, a little bit from ISO, a little bit from ASTM, and so they've kind of picked and choose from those test methods to get things that work for their market, and it's the same, across the globe. The only few differences would be a couple different places, but those two or three are probably the leading safety footwear norms. Like for instance, Australia is really a modified version of ISO standards with a couple tweaks. Which is what we normally see throughout the globe.
Thank you, Matt, and thank you, David.
Okay, so thanks, Matt. Thanks, Jose, both for the good presentation. And for all the public, los invitamos a esperar nuestro siguiente panel, navegando por la plataforma. No se olviden entrar al módulo Expo, ahí van a poder conocer un poco más de todas las marcas que movemos. Timberland PRO tiene un stand en el cual van a poder entrar y conversar con José. Cualquier duda o consulta que tengan, pueden entrar a la zona networking y en la zona aliados también. Y en nuestro siguiente bloque tendremos un conversatorio entre Carlos Alarco de Bechtel, Alfonso Panizo de Engineering Services y Mauricio Melinchon de EFC. No se lo pierdan y no olviden que al final del día tendremos un sorteo para todos los asistentes al evento, así como descuentos especiales en nuestra tienda online. Muchas gracias a todos. Thanks, Matt. Thanks, Jose.
Thank you, David. Thank you, Jose.
Thank you. Pleasure.